Graphing quadratic functions in standard form. Okay, the standard form for a quadratic function is y equals ax squared plus bx plus c, much similar to the standard form when we're using the quadratic formula. Okay. Just as in vertex form, if the a value is positive, the parabola will open up, and if the a value is negative, the parabola will open down. Okay, finding the line of symmetry is a little bit different. Okay, when we have standard form, we use an equation to find the line of symmetry. Okay, the equation is x equals negative b over 2a. For example, if we have the equation y equals 3x squared minus 18x plus 7, we fill in a negative 18 for b, we fill in 3 for a. Well, the opposite of negative 18 is positive 18 over 2 times 3, which gives us 18 over 6, or 3. Okay? Since our symmetry line is a vertical line, the equation will be x equals 3. Okay, after we have the line of symmetry, we want to find the vertex. Okay, since we know the symmetry line goes through the vertex, we're going to use the x coordinate that we find. We're going to substitute it into our equation, and we're going to solve for y. Okay. So here's another example. Suppose we had the equation y equals 2x squared plus 8x minus 3. Okay, well, we substitute in our b and our a into negative b over 2a to get the line of symmetry x equals 2. Okay, next, we're going to plug that x value in and solve for y. So our original equation, negative 2x squared plus 8x minus 3, we substitute 2 in for x. We do the order of operations, so we square 2 and we multiply, and then we add and subtract, and we end up with a y value of 5. Okay. So the x value is 2, the y value is 5. So since the vertex is an ordered pair, the vertex is 2, 5. Okay, so there are 3 steps that we're going to use when we're graphing parabolas in standard form. First, we're going to find the line of symmetry. So we're going to use x equals negative b over 2a. Step 2, we're going to find the vertex. So we're going to substitute our x value into our equation and obtain the y value. And then we're going to write our vertex as an ordered pair. Okay, step 3 is what we used to graph a parabola in vertex form. We're going to make a table of 2 extra values close to the x. Okay, and then we're going to use the idea of symmetry to reflect and find 2 points on the other side of our symmetry line. And then we're going to connect them to form our parabola. Okay, so let's try a full example. Okay, so we want to graph 2x squared minus 4x minus 1. Well, step 1 is to find the line of symmetry. So we're going to use our formula x equals negative b over 2a. Well, in this case, b is negative 4, a is 2. So we substitute in a 2 for a, we substitute in a negative 4 for b, so a negative 4 becomes positive. And we end up with 4 over 2 times 2 is 4, so 4 over 4 gives us 1. Okay, so our line of symmetry is the line x equals 1. Okay, it's a vertical line at 1 on the x-axis. Step 2, we find the vertex. Well, to find the vertex, we take the value we found for x, we plug it into our equation, and we solve for y. Okay, well, we know from the last slide that x is 1. So if x is 1, we're going to plug that in, so we have 2 times 1 squared minus 4 times 1 minus 1. Okay, and we do out our order of operations. 1 squared is 1, 2 times 1 is 2, 4 times 1 is 4. Well, 2 minus 4 minus 1 is negative 3. Okay, so the vertex is 1, negative 3. So we're going to plot that point on our graph. Okay, so now we need to find 4 other points on a parabola and complete our graph. Okay, well, what we need to do is we want to find 2 points either to the right or to the left of our symmetry line. Find the y values and then plot those points and use the idea of symmetry and reflection to do it. So the first thing I'm going to do is decide, well, do I want to go to the left or to the right of the line? I'm going to the right of the symmetry line. So I'm going to let x equal 2 and x equal 3. Well, if x is 2, we substitute 2 into our equation. So we have 2 times 2 squared minus 4 times 2 minus 1 equals negative 1. So when x is 2, y is negative 1. I'm going to plot that point, and then I'm going to choose to let x equal 3. Well, when x is 3, I'm going to plug it into the equation. So I have 2 times 3 squared minus 4 times 3 minus 1. I do that out. 3 squared is 9 times 2 is 18 minus 4 times 3 is 12 minus 1. I get 5. So when x is 3, y is 5. I'm going to plot that point. Okay, since I know I can fold my parabola over the line of symmetry, I know that I have a point to the left of the line that matches up with each of the points to the right of the line. I'm going to find those points. Okay, I have the point 0, negative 1, and I have the point negative 1, 5. Then I'm going to connect them to form my parabola. And I'm done. Okay, your turn. Complete the next 2 problems on these slides. Make sure you follow the steps. Find the line of symmetry using negative b over 2a. Find the vertex by substituting our x value in from step 1 and solving for y. And find 4 other points by choosing points to the left or right of the symmetry line, and then using the idea of symmetry to find 2 other points. So you have 2 problems to do. The first one is up there, and the second one. Good luck.